Let's look at Lewis structures and how we can use Lewis structures to understand how an ionic compound forms. When you draw the Lewis structure, it's quite straightforward. You start with the symbol for the element. So, for example, if we have lithium, and we look up lithium on the periodic table of the elements, we find that lithium has 3 electrons. Now, the first 2 electrons go to fill the inner shell. That leaves 1 electron for the outer shell. So the Lewis structure looks something like that, with lithium and 1 extra electron. If we wanted to choose something else, for example, let's say magnesium, let's start by looking at the periodic table, and I would discover that magnesium is in group 2. And so therefore it ends up with 2 electrons in its outer shell. So to show magnesium as a Lewis structure, we would show that it has 2 extra electrons. There's just an assumption that all the inner shells here, doesn't matter how many there are, because the chemistry we're interested in is only happening in the outer shell. Now, how do I draw these as ions? It's fairly straightforward. Lithium would like to get to a point where it has a full shell of electrons. Now, there's 2 possibilities. It could gain, remember this shell will need 8 electrons to be full, so it could gain 7, or it could lose 1. Losing 1 is a whole lot easier. So if I were to show the Lewis structure for lithium having lost that 1 electron, notice there's no electrons drawn here, and I've lost an electron. So if I lose an electron, that means I have 1 more proton than electron, so I end up with a charge of +1. And we could write 1 plus, but it's understood that if we just put the plus, that this is an ion with a charge of 1 plus. Notice also that because it's an ion, the convention is just put some square brackets around it. What does magnesium look like? Well, we start with the symbol. How many electrons have we lost? We've lost 2 electrons, square brackets saying, hey, this is an ion. And so then I say, what's the charge? I lost 2 electrons, so the charge is 2 plus. Okay, this is all very interesting, but how is it going to help us understand how ionic compounds are formed? Well, let's look at a compound formed with lithium and with its extra electron, and let's say fluoride. Fluoride has 7 electrons in its outer shell. So if it has 7 electrons in its outer shell, it can get a full shell of 8 by just gaining 1 more. Where's it going to get it? Well, if we put lithium and fluorine together, this electron will end up going over to the fluorine. Lithium will end up with a full shell and have a charge and be an ion now with a charge of +1. And fluorine will gain that extra electron, so we're going to draw now that it has 8 electrons around it, and it has a charge of -1. And since this one has a negative charge and this one has a positive charge, it's an ionic compound. The total charge is neutral, but we also know that the negative and the positive are attracted to each other. And so these are chemically bound together in an ionic bond. And what identifies that ionic bond is the fact that the electron has been given over. It is not shared, it is given over completely. Let's consider what would happen, say, with magnesium and fluorine. So there's my fluorine with its 7 electrons. So 7 electrons here, 2 electrons there. Now magnesium wants to get rid of 2 electrons, but fluorine is only going to accept 1. So in order to actually make this reaction work, what we're going to need is 2 fluorines, 2 fluorine atoms for every one magnesium, because magnesium's trying to give one away, give two away, and fluorine's only willing to accept one. So when I draw this one, I'm going to draw the ions. I'm going to start with the fluorine. Now remember, 1, 2, 3, 4, 5, 6, 7, 8. So it's gained an extra electron from what it had before. So it has a charge of -1. I'm going to put the magnesium in the middle because it gave away two electrons. It's going to have a charge of 2+, and another fluoride ion here. Now let's think about why I set it up that way. What do we know about the law of electric charges? This negative ion and this negative ion are going to repel each other. So if they're right beside each other, they're going to push each other as far apart as they can, which will end up being on opposite sides of the magnesium ion. Now, when we study this a little more, what we're going to discover is that these ionic compounds will tend to form themselves into a crystal lattice. But that, in essence, is how ionic compounds form using Lewis structures to help picture what's going on.